Yes, this is Solo for Math. Again, today we're going to look at logarithms. This is a continuation of the series about logarithms for A level. So today we want to look at an aspect of change of base in logarithms. So we are going to consider this by looking at a question like this one. Show that log A base B is equal to log A base C over log B base C. You can clearly see that the base here is changed to C. Okay, so any logarithm at any base can be changed to another base. So we're going to look at the procedures. Let's start right there. So we want to show, so we're going to start from the left hand side. So from the left hand side we shall let y equal to the left hand side, which is log A base B. Alright, so we looked at changing from logarithmic notation to index notation. So we change this to index notation. We said this exponent will come and power the base B, so the base remain B to power this exponent. Now this argument comes down, so it's like you have B to power y equals to A, or A equals to B to power y. Now this is the step where we're introducing the new base. So like you introduce log to a base C, which is needed. Also this side, once you do it on both sides, it has no problem. When we introduce it to the left, you also introduce it to the right. Just like here, we've just introduced the base, the logarithm to base C. It doesn't change anything. Okay, so after that, you remember we say we looked at a law where if we have the argument as an index, this power can always come down. So we have y log B base C equaling to log A base C. So when we divide through by log B base C on both sides, we shall remain with y on one side. So meaning y, let's divide base C equals log A base C divided by log B base C. We want to remain with y divided by log B base C. This and this will reduce, will go, so remain with log A base C over log B base C. But remember, we let our y to be this, so where there is y we put log A, meaning this is log A base B equaling to log A base C over log B base C. Yeah, as simple as that. So this is what it means to change the base. So whenever you're given an n logarithm like log A base A and you want to change it to any base, for example to base C, then I'm going to show you a simple way of remembering this, because every time you don't have to drive this unless it comes as a question. You don't need to drive it. So this is what you can do to remember. If you have log A base B and they want you to change it to base C, okay, you can do this. You can draw a line dividing, crossing out, like dividing the log, leaving A up and B down. So that one, that should help you to remember that we are like dividing the log of A over log B. Okay, now what is the base? After dividing, then the base is the new base that they want. You just put this there. For example, if if you want to change, for example, log 3 base 4 to base 2 we do the same, divide through this so that this argument remains up, the base also remains down, and then you know that is equal to, you divide in the log, so it takes on the 3 in the numerator, and then it takes on the 4 in the denominator. Then you give it the any base that is given. So here we want to change to base 2. So it will be simply that. So we are going to look at, and before we look at other examples, we've proved that log a base b is equal to log a base c over log b base c, where c is a new base. And remember, we said the base should be any number, any positive integer, as long as it is not 1, any positive integer bigger than 1. So what if our c is equal to a? We want to look at a case where you change it to a base, but the base which is the argument, like your base, the new base is argument. So it means that log a base b will be equal to, where there is c here we put a, so it will be a over log b base a. So you see where we said if the argument is equal to the base, then this, the log of that is 1. So it's like this will give you 1 over log b base a. So whenever you're changing to a base, to a base here that is equal to the argument, you have 1 in the numerator, and then this, like these ones will, it's like sort of an inverse. The a will become the inverse, the base, and then the b will become the argument. For example, if you want to change, for example, log 5 base 6, you want to change it to base 5. Like the new base is the argument of the previous logarithm. So this one will be equal to log 5 base 5 over log 6 base 5. And we know this is, since the base is the same as the argument, this will be 1 over log of 6 base 5. That is what we meant. Even when you have log of 3 base 7, you want to change this to base 3. This one is the same as 1 over log 7 base 3. As simple as that. So let's look at some applications. Let's look at this example here. Want to solve for x. You're given log x base 2 minus log x base 8 equals to 4. Someone wants to ask, when do we change the base? Sometimes they will not tell you to change the base, but you realize that it's necessary for you to go on with the number. Like in this case, you can only proceed after changing the base here, and we always change from the big base to a smaller base. And when you're changing to some base, like in this case, change to some base that is already existing. For example, I'll change this to base 2, okay, because it's already existing here. And then another thing, I'm realizing that this 8, when I put it as the argument, I can write it as a power of 2. So let's start by changing this base using what we've learned to base 2. So this will be log x base 2 over log 8 base 2 equaling to 4. So you can see that this can be written as a power of 2. So let's go on and simplify that. So this is log x base 2 over log, this one I can write it as a 2 to the power 3 base 2 equals to 4. Now this 3 drops. If it drops, remain with log x base 2 minus log x base 2 over, this will be a 2, so it will be a 3 log 2 base 2 equaling to 4. This is a 1. You remember we said if the argument is equal to the base, then this goes to 1. So meaning we shall have this as log x base 2 minus log x base 2 over 3 equals to a 4. So for simplicity, let me let my log x base 2 to be equal to maybe y. If it is y, then I'll have here y minus y over 3 equals to 4. I can start by taking out this denominator. I can multiply through by 3 throughout, by 3 by 3. This will be 3y, okay, minus y equals to 12. And when we continue, this will be a 2y equals to 12. So when you divide through by 2, you get 6. But remember, we let our y to be equal to, it was log x base 2. So meaning our log x base 2 is equal to 6. So to find x here, this x, if I change this to index notation, you realize that the x will go down and then the 6 will come and power 2. So meaning we shall have x equals to 2 to the power 6. So our x will be, what is 2 to the power 6? That is a 64. And you have the answer. So thank you for watching. If you have any questions, put it in the comment section. Don't forget to like, share, and to subscribe to the channel for more lessons that are coming. Thank you for watching.